What's up guys, it's Iman Fiaz and today's video is on AQA A-level chemistry bonding question paper from physics and maths tutor. Question 1, before I carry on, let me get my calculator. I don't think I'll need a calculator because it is bonding. So yeah, but just in case I do, there we go. Which molecule is not able to form a coordinate bond with another species? Can you guys hear me? Can you guys see my screen? Yes, you guys can. Okay. Well, the thing about carbon, CH4, methane, is that it can only have a maximum of 4 bonds, right? And therefore it can't form a coordinate bond. Because coordinate bond where one atom contributes as pair of electrons to a covalent bond, but CH4 can't do that. And if it goes to CH3, it's going to be very unstable. Whereas this BH3 can accept a lone pair of electron, NH3 can, and H2O can donate. CH4 cannot. Which species has square planar shape? XCF4. This is a textbook example of a square planar shape. But if you were given an unfamiliar one, multiple choice question, which you probably won't, but if you was, then you'd use the method, which I will go through in a later video. Which bond has the most unsymmetrical electron distribution? Hydrogen and oxygen. Which statement about inorganic ionic compounds is always correct? They dissolve in water to give neutral solutions. No. They release energy when they melt. No. They contain metal ions. Metal cations, or positively charged ions. No. They form giant structures. Yes. Inorganic ionic compounds always form giant structures. And that's a fact. I would memorize this multiple choice question. They always form giant structures. Which species has a lone pair of electrons on the central atom? Carbon dioxide, sulfur dioxide. Carbon dioxide is not going to have a lone pair of electrons on the central atom. Sulfur dioxide will actually. Sulfur dioxide will have a lone pair of electrons on the central atom. And again, this is the same method used for this one to identify which species has square planar shape. In which substance do covalent bonds break when it melts? Hexane, ice, iodine, silicon dioxide. Covalent bonds breaks when it melts. It's going to be iodine. No, sorry, not iodine. It's going to be silicon dioxide. SiO2. Covalent bonds break when it melts. Question 7. Which molecule are all atoms in the same plane? So what does this even mean? Well, let's draw out these molecules. So methane is it. So 2 carbons. You got CH3, and this is obviously an aldehyde. Whereas if I look at B, CH3 and H2, and if I look at C, Cl. That's the structure of C. Whereas if I look at D, CH3. So which molecule all the atoms in the same plane? It's going to be C. Question 8. Which molecule has a permanent dipole? BF3. No. Wait. SCl4. No. NH3. BF3 boron is in group 3. So no. SO3. Oh, it's going to be NH3 ammonia. Question 9, which substance contains delocalized electrons? Graphite, obviously. Question 10, which polymer has hydrogen bonding between the polymer chains? Kevlar. Question about shapes of molecules in iron. Draw the shapes of NCl3 and of NCl4+. Well, NCl3, well, you got nitrogen, and then you've got Cl, Cl, Cl. Now the thing about nitrogen though, it's going to have this lone pair of electrons in nitrogen group 4 bonded to 3 atoms. But in this case, NCl4 plus, square brackets, nitrogen. In this case, it's going to be like this instead. Cl positively charged. The name of NCl3, pyramidal. The bond angle NCl4 plus, well the thing about NCl4 plus, it's what? It's yeah, so it's going to be bond angle 109.5 degrees. And the explanation bond angle NCl4 plus, electron pairs repel equally / electron pairs repel to be as far apart as possible. Put this on a flashcard because the mark scheme is so specific. So, you know, learning from a textbook is perfectly fine. I'm just saying in general. That's what I do. But you also need to do a bunch of past paper questions. Which compound contains a coordinate bond? HF? No. NH3? No. CHCl3? No. NH4Cl? Yes, does contain a coordinate bond. Alhamdulillah. Alhamdulillah. Explain why pentan 2L has a higher boiling point than pent-1E. If I saw this question in exam, I'd be quite happy because I just need to say pentan 2L has stronger intermolecular forces as pentan 2L has hydrogen bonds, whereas pent-1E has van der Waals. Van der Waals forces only. Pentan 2L has stronger intermolecular forces. Pentan 2L has hydrogen bonds. Pent-1E has van der Waals forces only. I wouldn't include that part because I would just say it has van der Waals forces. Pent-1E is formed by the elimination of water from pentan 2L. State the reagent and condition for this reaction. Alhamdulillah. And outline the mechanism for this reaction. So with pent-1E to pentan 2L, I'm going from alkene to an alcohol. It's going to be the reagent. It's even if you get this part wrong, it doesn't really matter. But it is concentrated H2SO4 / concentrated H2PO4. The main part is the mechanism, because that's going to be at least 3 marks. And the condition hot. So you could state a temperature range if you want, but hot is perfectly fine. Concentrated H2O3 or concentrated HPO4. Hot is the condition. So outline the mechanism from pent-1-ene is formed by elimination of water from pentan-2-ol. So I need to draw out pentan-2-ol. How do I draw out pentan-2-ol? Well, it's pentan, methane, ethane, propane, butane, ethane, propane, butane, pentane, 2-ol, hydroxy groups on the second carbon. I'm going to fill in the hydrogens. Just like that. And then what happens? Well, remember, with this mechanism, I've got a H plus lying here. I've got this oxygen with a lone pair of electrons, and it bonds to this H plus. Then what happens is, this is going to take, okay, let's just do it. I'm not going to fill in the hydrogens just for, no, I might as well. Then you've got your CH3, that's CH2, but what happens basically is that oxygen becomes protonated. So protonated means positively charged. And then you go from the middle of, from this middle of the CO bond to the oxygen which is positively charged. And then what happens is okay, I need to put that there instead. Then that is positively charged carbon. And then what happens is, well, now a hydrogen is going to come. Now, is it the hydrogen from here to here? Or is it from the hydrogen from here to here? Well, what does it say in the question? It says I want to form pent-1-ene. Now, if I go from the middle of this carbon hydrogen to this bond, that's pent-2-ene. That's not pent-1-ene. So it has to be this way. And yeah, that's it. Yeah, that's it. That is it. So middle oxygen lone pair electrons bonds to this H plus, and because it's done in acid-base catalyst. Then you've got this. Well, then what? This oxygen is now protonated, and then from middle of the carbon oxygen to the oxygen. Now the carbon's positive charge, carbocation, and then you just need to read the question properly, and you want to form pent-1-ene, so it's going to go from this carbon hydrogen to here, because that will form out the double bond here. But if you did it here, you would get it wrong, and you'd actually lose a mark because that would form pent-2-ene. It says pent-1-ene, so the double carbon-carbon double bond has to be on the first carbon. That's pretty good recap of year one mechanisms. Do not, guys, please do not forget year one mechanisms. I mean, do not not revise them because they definitely do come up. Stage one electron pairs. Okay, so XeF4 is square planar. I already know that, but I'm not going to talk about that now. I'm going to say it has 4 bonding pairs and 2 lone pairs around Xe, whereas PF3 has 3 bonding pairs and 1 lone pair around P. Stage 2, the shapes. XeF4 is square planar, or you could draw out the shape and then say PF3 is pyramidal. And then say electron pairs repel to be as far apart as possible, or you could say lone pairs repel more than bonding pairs of electrons. And you guys can't see that, but there you go. There you go. Lone pairs repel more than bonding pairs of electrons. And then stage 3, because it does say in the question, and how the shape influences the forces that affects a melting point. So I need to talk about the intermolecular forces. Well, XeF4 has what? What does it have? Well, it's completely symmetrical, so it's not. It doesn't have. First of all, it doesn't have hydrogen bond. When I need to do this, obviously in A-level chemistry, there's 3 types of main bonds in these type of questions, right? Van der Waals, hydrogen bonds, or dipole forces. And if I want to identify which one, let's look at XeF4. Let me draw it out as well, because I definitely have to draw it out so you guys understand what's going on. So let's start from the bottom. Let's start from top. Sorry, Van der Waals forces. Let's start from the bottom. Dipole forces. Well, what do you notice about this? It's completely symmetrical. So it's not going to have dipole forces, because in order to have dipole forces, the molecule must be unsymmetrical, because if it is symmetrical, the dipoles will cancel out. Hydrogen bonds, definitely not. Just by memorizing the definition of hydrogen bonding, you know it's not hydrogen bonds. Therefore, it must be van der Waals. So it has van der Waals forces. That's how I would look at it. I think that's a very good way of doing it. So it has van der Waals forces. And then PF3 has, well, let's do the exact same thing for PF3. Let's do the exact same thing for PF3. So what we've decided XeF4 has van der Waals forces. What about PF3? We'll do the exact same thing. Van der Waals. Well, I know it's not going to have van der Waals now because we're comparing them in terms of boiling point. But I guess it could, I'm not sure. And then talk about bigger molecule, whatever. But yeah, we can't assume that it's not going to have it. Hydrogen bonds and then dipole forces. Okay, PF3, P, F, 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 and it's got a lone pair of electrons. What's it going to have? Well, it's definitely not hydrogen bonding. So I'm left with van der Waals and dipole. Can it be dipole forces? Yes, it's not completely symmetrical. It's not. But it also has van der Waals as well. Yeah, so it's got. So I'm going to talk about that. That's got dipole. It does also have van der Waals, but the idea that it has a dipole, and that's going to cause the increase in melting point. I'm going to assume. So I'm going to say PF3 has dipole forces and van der Waals, but that's not really relevant. Okay, and therefore it's got stronger intermolecular forces and van der Waals, but stronger intermolecular forces in XeF4 as it has more electrons, which has a bond angle of 109.5 degrees. It's not graphite, it's diamond. It's diamond. It's a question about compounds that contain fluorine. It's claiming about fluoride is larger than sodium ion. Think about fluoride ion has fewer protons than a sodium ion, hence weaker attraction between nucleus and outer electron. Let's just think about that, okay? I decided fluorine has fewer protons than the sodium ion. I think any student, just look at the periodic table and you can find out it's got fewer protons. It actually has 2 fewer protons than sodium ion. Okay, that's your first one. But then why does this mean weaker attraction between nucleus and outer electron? Well, if it's got fewer protons, its atomic radius is going to be bigger. And if its atomic radius is bigger, it's a weaker attraction between the nucleus and its outer electrons. That's why. Explain in terms of sugar-strong bonding why the melting point of sodium fluoride is high. So giant ionic lattice. No, not giant ionic lattice. Electrostatic forces of attraction between oppositely charged ions. Hence, lots of energy needed to overcome these forces. And that just means it's got strong ionic bonding. Name type of bond form when HF reacts with H+. Well, it's dative covalent bond. That's the easy mark. Well, actually, no. Most students would say, including myself, coordinate bond. So let's just say it's that. Because a lone pair of electrons is donated from fluorine. Well, the lone pair of electrons is not going to be donated from hydrogen, is it? So it must be fluorine. And the definition of coordinate bond, lone pair of electrons donated from a coordinate bond. A lone pair of electrons donated from this F to form a coordinate bond. Draw the shapes of this SB F6 minus and the shape, name of shape. So SB, negative charge. I've got F here, I've got another one 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 here, and I've got another one here. 1, 2, 3, 4, 5, 6. Octahedral. H2F plus, square brackets, positive charge, F, hydrogen, hydrogen. It's got one lone pair of electrons here, there's a pair of lone pair of electrons there, bent. Hydrogen fluoride. Alhamdulillah. Reacts with ethine or ethine C2H2 as shown in the equation. All compounds in the gaseous state. This table shows some mean bond enthalpy data. Use data in table to calculate a value for the bond enthalpy of a CF bond in the product. What I would recommend for these questions after I have done a lot of them, I think, and I've made a lot of mistakes on these questions, is don't jump into it. There's some calculation questions you can. I don't think this one you should, because it's a relatively easy topic, isn't it? It's once you memorize the formula. But that's why you don't want to do it, because 3 marks is still quite a bit, and you make one mistake, you're gonna get the wrong value, and that's why you can't really. You want to take your time anyway. So I want to find a bond enthalpy of a CF bond. Where's the CF bond? Here. I know delta H is up. So minus 179 equals energy required to break bonds minus energy released when new bonds are formed. So I'm going to write this as breaking bonds minus energy released when bonds are formed. forming bonds. So minus 179 equals energy required to break bonds minus energy released when new bonds are formed. So breaking bonds is this. We've got a HC, or CH, which is 412, plus a CC, 837, plus a CH, 412. I don't think this topic does not come up in A-level paper. I've seen it come up in A-level paper. It came up on mock paper, and so many students struggle with it, including myself, students, because you don't practice this skill that much. That's why I think. Plus HF, you have to do this in your meantime, because school isn't really going to teach you this topic to master the skill. Minus energy released when new bonds are formed. 1, 2, 3, 4. So 412 times by 4 plus carbon-carbon bond 348. And don't be fooled, there's 2 carbon F bonds, which I almost fall for, plus 2y. Simplify it. Don't just simplify the first bracket, then simplify the second bracket, and then you move on. So 412 plus 837 plus 412 plus 562 plus 562 is 2785. Minus 412 times by 4. My answer plus 348, 1996 plus 2y. And then what I would do is I just treat this as imaginary 1 here, and I would just multiply it out. So I get minus 179 equals 2785 minus 1996 minus 2y. And then you can see how we go from here. What I would do is I leave this here, move the 2y here, so I get 2y equals this, and then add 179. So 2785 minus 1996 plus 179 divided by 2. 484. 484. Whew. I think this part is where I used to make so many mistakes, but just expand the bracket, treat it as a minus 1, expand the bracket, then you ain't going to make any error mistakes. Then you just move it to the right hand side. Okay, that's a simple calculation, and then I just add 179, and then I just divide by 2. Which substance has delocalized electrons? Graphite. Which change occurs when water is vaporized? Ooh, what a question. Intermolecular forces are overcome. Not covalent bonds. When water is vaporized, intermolecular forces are overcome. Question 19. Which compound has the highest boiling point? Now, anytime you see this, immediately I'm looking for hydrogen bonds, hydrogen bonding. So that doesn't have hydrogen bonding. Neither does... Well, let me just draw that out real quick. Yeah, now I'm going to have to actually think, because hydrogen bonding is when electron deficient hydrogen is bonded to an NOF atom. But in this case, it's... I'm just going to fill in the ending of the part, CH2F. So the F is actually bonded to a carbon. It's not bonded to a hydrogen, so that's fine. With C, I've got this C. I'm going to draw the full thing for this one, because obviously it's slightly different. I'm working with an aldehyde, so I don't want to make any silly mistakes. Double bond over here, hydrogen here. Is the electron deficient hydrogen bonded to an NOF atom? No, it's bonded to a carbon. So it's not that, therefore the answer must be D. But I also want to show you guys why it is D as well. So if you look at D, methane, ethane, prop, 1, 2, 3, 1, 2. It's carboxylic acid, carbon-carbon double bond, oxygen, OH. What is electron deficient hydrogen atom bonded to? It's bonded to an oxygen atom. And remember, in order to have hydrogen bonding, electron deficient hydrogen atom needs to be bonded to an NOF atom. Is it bonded to an NOF atom? Yes. is bonded to an oxygen, therefore that is the correct answer. Well, I knew it would be anyway because of a process of elimination, but just to show you guys where that comes from. Question 20, draw a diagram show the strongest type of interaction between two molecules of ethanol. So I've got C2H5, I've got oxygen, which is delta negative, and it's got two lone pairs of electrons, and it's got hydrogen positive, and then the second part is probably more difficult, but how would you do this? Well, think about it, okay? I've still got the oxygen with the two lone pairs of electrons, I've still got the delta negative charge, I've still got the C2H5, I've still got the hydrogen which is positive. It just goes from lone pair of electrons to there. It's that easy. I would put this on a flashcard as well. Question they could definitely reuse. And I don't think a lot of students will get this correct. You probably need all of the detail. So yeah, definitely put this on the flashcard. In terms of intermolecular forces involved, explain difference of both boiling points. Ethanol, methoxymethane. Let's draw out this, wherever this is. Okay, ethanol. Okay, I already know what I'm going to say. Ethanol has hydrogen bonding between its molecules, whereas methoxymethane has what? Well, methoxymethane, oxygen and the CH3, one second, guys. Okay, yeah, it's not a carbon double bond oxygen. And then you say, guys, methoxymethane has. Well, it definitely has van der Waals, and that's all I'd say. Has van der Waals between its molecules. And then you say a simple statement like hydrogen bonds HB are stronger. Stronger. Obviously, don't write HB in your exam. Write hydrogen bonds. Doesn't methoxymethane? Why does methoxymethane have dipole-dipole forces? Surely it shouldn't, because the dipole-dipoles cancel out since methoxymethane is a symmetrical molecule. Draw the shape of POCl3. And then draw the shape of ClF4 minus. Well, with this, I always draw square brackets because I've seen a bunch of mark scheme using it. Doesn't mean all of them do, but if you do the square brackets, I don't think you can be penalized. Two lone pairs of electrons. A name of shape of POCl3 trigonal planar. Actually, no. POCl3 tetrahedral. ClF4 minus is square planar, and remember, in a square planar, the bond angle in a square planar is 90 degrees. So that's pretty nice. This part's really nice. This part, that's pretty nice, and yeah, I guess that's pretty nice as well. Which is not responsible for the conduction of electricity. That one, the lone pair of electrons and water molecules. Question 22, draw the shape of a krypton difluoride. Krypton difluoride, so 2 fluorine, and it's also going to have 3 lone pairs of electrons. The name of the shape is linear. The bond angle is 180 degrees. Explain how lone pair of electrons and oxygen atom influence bond angle of oxygen difluoride. Number one thing, anytime you get a question like this, lone pairs repel more than bonding pairs of electrons. And what does that mean? Well, that means bond angle will be lower. And I know one lone pair of electrons reduce bond angle by 2.5 degrees. So 2.5, 5, 7.5. So regular tetrahedral is what? 10. Actually, you just need to say lower. Bond angle will be lower than regular tetrahedral angle. You don't need to get into specifics of how much lower and that. Reduced type of intermolecular force in SiF4. Van der Waals forces. Again, do that thing. Hydrogen bonds, definitely not. There's literally is no hydrogen, so we can't have hydrogen bonding. Van der Waals forces or dipole-dipole. Dipole-dipole was completely symmetrical, so no, therefore must be Van der Waals forces. Van der Waals forces as uneven distribution of electrons in one molecule induces a dipole in neighboring molecule. However, as symmetrical molecule, hence dipoles cancel out. But you could also say, because it says why no other type of intermolecular forces, plus as no hydrogens are bonded, well, it can't be Si are bonded to fluorine, and no hydrogen bonding. That's really getting into the question. But yeah, all you need is Van der Waals forces as uneven distribution. Copy and paste this uneven distribution of electrons in one molecule induces a dipole in a neighbor molecule. However, as symmetrical molecule, hence dipoles cancel out. Which role shows the bonding in ammonium chloride? Ammonium chloride, all 3 of them. Question 24, which molecule does not have a permanent dipole? If it does not have a permanent dipole, I'm thinking, okay, it's symmetrical. Right? So if it's symmetrical, which one's symmetrical? CH3Br is definitely not. CH2Br2, let's have a look. CH2Br2, Br2. CH2Br2. Forget that. I can already see it's going to be CBr4 because all 4 of them are the same. C, Br, 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 Br. So it will cancel out. Therefore, it won't have permanent dipole. And remember, because Van der Waals forces uneven distribution of electron molecule induces dipole in neighbor molecule, but it's a symmetrical molecule, hence dipoles cancel out. Therefore, it doesn't have dipole-dipole forces. Same logic applies here. Symmetrical molecule dipoles cancel out, doesn't have permanent dipole-dipole forces. Give the meaning of the term electronegativity. The power of an atom to attract a pair of electrons in a covalent bond. Explain how permanent dipole-dipole forces arises between molecules. Difference in electronegativity leads to bond polarity. Dipoles do not cancel out, hence the molecule has an overall permanent dipole, and there is an attraction between delta positive on one molecule, on one molecule, and delta negative on another molecule. For these questions, this one is just to have intermediate force van der Waals and even distribution electron molecule, just dipole in neighboring molecule. However, is symmetrical molecule, dipoles cancel out and no hydrogen bonding to F, hence no hydrogen bonding. And this one explain how permanent dipole-dipole forces in hydrogen chloride molecules difference electronegativity leads to bond polarity. Bond polarity, dipoles do not cancel out, hence the molecule has an overall permanent dipole attraction between a delta positive on one molecule and delta negative on another molecule. I'll just put it on the flashcard and just learn those. Place the tick in the final column is the molecular permanent dipole. SiH4 tetrahedral, pH3 tetrahedral, BeCl2, or you could say pyramidal, that's definitely linear, and this one, again, you could say tetrahedral. It's just distorted tetrahedral, but you don't need to say that. Does it have permanent dipole? Well, let's look at this, how permanent dipole forces arise. Difference in electronegativity leads to bond polarity. However, bond dipoles do not cancel out, so the molecule has an overall permanent dipole, and the attraction between delta positive one molecule and delta negative another molecule. That's completely symmetrical, so it wouldn't have permanent dipoles. This, that would have permanent dipole, because the dipoles won't cancel out, therefore the molecule has an overall permanent dipole. This, that's completely symmetrical, so dipoles do cancel out, and this one, molecule will have a permanent dipole. Which compound has the highest boiling point? Anytime you see this, I'm looking for hydrogen bonding, hydrogen bonds, whatever you want to call it. This one, no, because I know it's not that one. This one, that's a ketone, that's in the middle. No, it's got to be that one. Wait, yeah, because electron deficient hydrogen is bonded to oxygen. It's got to be that one. I will. Oh, sorry, I skipped a question. Which is the correct crystal structure of a substance named? Diamond ionic? No. Sodium chloride giant covalent? No. Graphite metallic? Is iodine simple molecular? You do need to know that anyway from part of the spec, so you should be able to spot that immediately. But in this case, why is it A? Because if you draw it out, CH3, CH2, CH2. If you actually draw it out fully, it's actually the oxygen, then the hydrogen. In order to have hydrogen bonding, the electron deficient hydrogen atom has to be bonded to an NOF atom. Is it bonded to an NOF atom? Yes, it's bonded to an oxygen. Therefore, it has hydrogen bonding. That's the end of the bonding question paper. Hopefully, you guys found it useful. If you did, please like, comment, and subscribe.